We are entering now section 6, which is the last section devoted to actually analyze our data. Since the next section will teach you how to report your EDA results with R Markdown. I think it's therefore interesting to review the learning framework I have introduced it at the beginning of this course, so to understand how far we came with previous sections. Within the first section, we set up the general structure of an EDA project, focusing on general principles, tips and tricks to avoid troubles when developing EDA project with R. We have then moved to sections 2 and 3, where we have learned how to understand the structure of data and investigate their quality. Performing this kind of preliminary checks allows to avoid that problems within data can ruin final results of our data mining activity. Moving to section 4 and 5, we have started taking our variables one by one and then in pairs to study their distributions and the most relevant characteristics. This was done employing both summary statistics and data visualization. You should always perform this kind of analysis, since they can provide crucial elements for the subsequent activities in your data analysis. You could, for instance, discover that some of the attributes available in your datasets are useless or even dangerous for your subsequent analysis. And we have finally arrived to the 6th section, where we are going to leverage both summary statistics and data visualization to assess if our model made the requirements of the most important data mining models. Once we will be done with this, the only remaining step will be to learn how to show all our EDA activities within a report with R Markdown. After that, you will be ready to autonomously perform this kind of analysis. Before diving into different assumptions, let's take the time to reflect about a concept which is really relevant when talking about data modeling: the purpose. When developing a model on your data, you have two possible alternative objectives. Describe how a target variable is influenced by a set of explicative variables, which is named exploratory analysis, or predict the value of a target variable based on a set of predictors, which is named predictive analysis. Understanding within which of the two alternative scenarios you are working is of paramount importance. We will often find people acting within an exploratory scenario as if they would be within a predictive one, and vice versa. But which are the main implications of being within one or the other scenario? Well, the main difference, and this is why we are talking about this within this section, is the set of assumptions you need to verify when applying models and algorithms on your data. On the first hand, if you are rather interested within an exploratory scenario, you have to make sure that the relationships found between the explicative and the target variables are true and sound and not spurious. You are also interested into understanding how much the explicative variables are able to explain the variability observed within the target variable. This therefore produces the need to verify a specific set of assumptions, and take care of a specific set of performance measures. On the other hand, if your objective is to predict the value of a target variable given a set of predictors, you will be way less interested into assessing the soundness of observed relationships and the ability to explain variability. All you will be interested in will be the accuracy of your predictions. As it is often the case, this is quite an extreme view, and the reality lays in the middle. This means that it will often be the case that your scenario will be a mixed one, where you're willing to sacrifice a bit of predictive power to gain a bit of more ability to explain relationship between exploratory and target variables. Nevertheless, always take the time to resonate about your purpose, so to your main focus, and invest your resources accordingly.